Hello, everyone. Welcome to Back to Basics. Plan is we're going to go back to the beginning of some of the programming content, and then we're just going to talk through this together. We're going to do some exercises, we're going to get some questions answered, and hopefully we come out of today a little bit stronger as a result. All right, so let's head over to reading code. So this idea of inputs and outputs, at this point, you've probably seen this come up like in a ton of different ways. So what are some examples you can think of stuff we've done where we turn inputs into outputs?
I mean, like the response, like when we're pulling API.
Love it. So we make a request to an API. API sends us data back. That's a great example of inputs and outputs. What else?
The DOM calculator,
What about the DOM calculator?
specifically being able to input any kind of integer we want and then create some kind of result from it.
Totally. So we enter some keys, and then we see stuff on the screen. Excellent. What else?
The Beyonce project.
Cool. What were the inputs and outputs there?
You'd take inputs of like Beyonce's hit songs where she had blonde hair, and it would output an array of objects.
Very nice. Keep going. Where else have we seen inputs and outputs?
I mean, we're just starting really with forms. I mean,
Yeah.
very literally inputs and outputs there.
Totally. User enters something into the form. They see something on the page as a result. How about just functions in general? Function takes in parameters and poops out the return value.
Would if and else statements also qualify? Or no?
Like if and else statements would be happening inside of here, but a little bit less input output on that. There's some other things that you can think of where we've seen inputs turn into outputs.
Would an iteration fall under this category?
So that'd be another thing that happens inside of one of these boxes, but isn't itself really inputs and outputs.
Would you count DOM manipulation?
Could. So that like could be a thing that's happening inside of the box. It could also be like I call the query selector method. So that's the input is like the tag, the class selector that I want or whatever, and the output is the first element that it finds that matches that. That would count as input and output. So this is just a pattern that we see over and over and over again. And you can even zoom out further on this and kind of view all systems from this perspective. So if the big box is dollars come in and orders, and the thing that comes out of it is cars and smiles, and this big box is Ford. Now, so many parts of this complex system inside of this that make that happen. Some of these are like human systems. So this might be like the people who make the cars and the credit arm and all these different parts of the organization, your technology team. Your technology team might have other parts that are inside of that. And then part of their process is using all of these little functions and programs. It's just input-output boxes all the way through. all systems you can kind of view through this input-output thing. And you can zoom it all the way out to like, what is the business? And all the way into how does this function work? Inputs turn it into outputs all the way down. Questions about this idea?
So the output is not the actions that are taking place in the box itself, it's the end product.
Bingo. So
Right.
that might be something you're seeing on a screen. That might be a return value of the function. That might be output of the business system. Like, not what's happening inside. That's how you turn the input into the output. And that could be all of the people systems that make that happen. That could be iteration and selection. All of that stuff is how you turn the input into the output. And like all of those have analogs in the real world too. So like iterating something, hey, can you process this stack of papers? Cool, that's iteration. You're doing the same thing to every piece of paper in the stack or whatever. Yeah, can you process all these orders? Anytime you hear all, that's some kind of collection of things that you're probably going to have to iterate over. Could be, show up to work at 9 a.m. unless it's Good Friday. Okay, unless, that's a conditional. So you are always showing up to work at 9 a.m. Unless, I'll write this out. If it's like Saturday, Sunday includes today, then you invert it, or today let's see, if today isn't Saturday or Sunday and today isn't vacation, or today isn't holiday, then go to work. It's the same kind of conditional logic thinking. Process all these papers. That's iteration. Should I do this right now or should I do this later? That's conditional logic. And everything that you do, you can't do multiple things at once. You're doing things one at a time. You might go back and forth, like serial single tasking, where, all right, I'm filling out this paper, then I answer this phone call, then I do this, then I do this, then I do this, then I do this. That's sequence. Sequence, selection, iteration. That's what programming is. What order are things happening in? Sometimes they do some things, sometimes they do other things. How do I get through all of these? All programs are fundamentally that. Questions about this idea? All right, onward. So in JavaScript, we do input output a couple different ways. So output, oops, oh, nope. There we go. So in JavaScript, we take input, like if I'm trying to get something that a user has in JavaScript, how do I do that? I want them to fill out, to give me their name, to give me their email address, to tell me what
Form.
Pokemon they want to see. Forms. So the way we get stuff into a browser app, most of the time, forms. It's not the only way, though. How else can the user tell us things?
Buttons.
Buttons. So like their events, when they click on something, that's input to us because we know what they clicked on. They go, oh, you clicked on the refresh button. Oh, you clicked on the process button. You clicked on the whatever. That's an input. Triggers a process. We want something they fill out, something that they know that comes from a form. And then at a smaller level, functions, call it function parameters. So inside of the box, functions are taking in inputs. Any other ways that we get input in JavaScript? It's a pretty good list. Go
What
ahead.
about like for statements?
So that's iteration.
Oh, okay.
So output. What are some ways that we do output in JavaScript?
Strings.
So strings are a data type. What do we do with them that counts as output?
Return.
Display them to the console.
Return.
Yeah, like
console. So we could log them. I heard another one in there. Returning it.
Return.
What else?
Sure.
Forms and buttons.
Throwing an error.
Errors are output. What else?
What about event listeners?
Let's see. So an event listener is something that's happening inside of the box. So like a button or some kind of event can trigger that. So that's the input. The output is something that it does.
its action,
Yeah. So whatever its action is.
whatever we coded its action to be, right?
Bingo. So it could be logging. It could be returning. It could be throwing an error. Or it's a big
CSS changes
one.
if we make it dynamic.
Oh yeah. So we could be changing the style. That's a valid output. What else? Big one.
Display.
Display it. How? Through what?
Append.
Like you're right there. You're talking about the right thing. There's a specific word I'm looking for.
Display. Dom.
There we go.
As a team effort, Efren.
Yeah.
So we read something out of the form, we take in a function parameter, we know that somebody clicked a button, and in response, we can log, we can return, we can throw an error, we can change the style, which is also just DOM manipulation, or we can add stuff onto the page. That's how we get input in JavaScript. That's how we do output in JavaScript. Questions about that? So this is one that a lot of people got wrong back when we were working on this. So let's talk through this a little bit because I think this is key to like kind of unlocking programming. So when you see, all right, string.split is not a function. So string.split happens right here. So if you want to debug this, it's like, yeah, strings. Every string has a split function. It's built into it. It's not possible to have a string that doesn't have a split thing. So if it's telling us that, we can deduce from that that this thing that we're calling string isn't a string. Otherwise, it would have a split method. So when we use console log, we know it's not a string. So what is it? That gives us a hint into how it was broken. And where that goes is right above this very first thing. Before anything else can run, I want to find out what string is. So we're visualizing that. When we want to inspect stuff, do it early. We want to inspect stuff here and here. By the time it gets to here, it's already gone through some stuff. It might not even make it to that code because in pretty much every programming language, if I put the log here before the for, it might not even run because the first time the browser gets an error in this function, it stops trying to run it. It won't keep going. It goes, oops, that doesn't work, so nothing after it runs anymore. So if I have a console log here, I'll never see it. I want to put it all the way up there. Now, if that doesn't run, that tells me this function never even executed. So then I go, all right, well, where did the function get called? And so then you go back from there, back, until you find something that you can log. Questions about any of that? This idea of inspecting as early as possible in the process.
So what was the correct answer to that one, since you said that a lot of people got it wrong?
So how can you use console.log to debug your program? Console log the string at the top of the function.
So would you put the console log under where it says words equals words reverse, or would you put it at the very bottom under the return?
At the very top. Because since this function runs top to bottom, I want to run it before I've done anything else.
So you would actually put it before the let reverse.
Correct.
That's where I have a problem. Like, I don't know where to put my console logs.
So that's the answer. We want to do it as early as possible so that we can, before anything else has had a chance to break.
Gotcha. Okay. Thank you.
Yeah, I actually just was looking, I'm following along on the Seeker LMS website, and it looks like I got that wrong because I thought the string was a function. So I did console log string in the function parameters and then closing bracket.
So I don't want to go very deep on this because this is, I think, literally the most complicated thing in JavaScript. This is a thing that like most pros don't know. But so this is a string. How come it has a dot split on it if it's a string? Because like dot split would kind of imply that strings are objects. Because like that's what you dot, right? You don't do like true dot split or something like that. You wouldn't do, let's see, reading code. I wouldn't do something like, true dot something. Like, that doesn't make any sense. Strings and Booleans and numbers, I can't do like one dot length. like that's not really a thing. So the complicated thing is that JavaScript takes strings and numbers and Booleans and all these things we call primitive values. They're called primitive because they don't have properties and methods and all that kind of stuff. They're the simplest kind of values that we have in JavaScript. What happens is when your browser runs it, it does this thing called boxing, where it turns them into objects that have these kinds of methods. Like I said, don't think that hard about it. It is the most complicated thing in JavaScript, but that's why a string has split methods and dot includes and like that kind of stuff. Other questions about using logs to debug something?
A lot of times I find myself in Edge or something and I try to console log something and it won't work, but I go over to Chrome and it does. Is that just going to be an issue, personal issue with my settings, or is that a common problem that you guys see in Edge?
I don't know. I have never tried to debug in Edge before. But
Okay.
like, this is an important, I think, to understanding how JavaScript works. The browser is the thing that's running your code. So, like the browser goes and fetches some JS file and gets it back. But the browser is what's going through that JavaScript code and executing it line by line. And so Mozilla's engine that does that is not the same as Safari. It's not the same as Edge's. And I guess that's it. There's basically 3 engines right now. There's so many different browsers, except there's actually only 3. There's Chrome, Safari, effectively, Firefox. And like the engines on these all of them except Safari are open source. So, oh, this is the layout one. Where is... Because the current Mozilla one is called... shoot, I had a buddy who worked on it. Why am I spacing on this? It's not Gecko. Where's our JS engine? Quantum, that was the name of it. Oh, I see. Quantum was like the name of the project. It was built on top of Gecko. Okay, that makes sense. So Firefox's is Gecko, and WebKit is the Safari one. And then the Chrome one, I can't remember if it's just called Chromium. Chromium is the open source version of Chrome. Let's see, Chrome JS engine. V8, there we go. So these are the engines that process all the JavaScript in these three browsers. And the idea is that, like, what a browser is like one of these JavaScript engines. There's also rendering engines that do the HTML and JavaScript part. And then you take those, and then you take what is confusingly called browser Chrome. So browser Chrome is like the URL bar, the bookmarking feature, your settings, apps, like all of that kind of stuff. Those three things together equals a browser. And so, like, most browsers are one of these engines plus different rendering engines and different browser Chrome. So like Edge, for example, current Edge, Microsoft stopped making their JavaScript engine, which was called, they've had a couple over the years, and their last one was actually pretty good. Chakra. So I think last year, somewhere in there, Microsoft gave up the ghost, stopped making their own browser engine, and now they just use V8 also. So Edge and Chromium are not actually that different under the hood at this point. But yeah, these programs take the input of JavaScript code, and the output is the result of executing that JavaScript code. These are the things that do that. Questions about that?
So not wanting to spend a ridiculous amount of time on engine because it's engines, just because it's not like what we're here for. But at the end of the day, the engine is really what's taking the JavaScript code and interpolating it through the beats and loops.
Yes.
So in video game world, we talk about the Unreal Engine.
Yes.
That's doing the exact same thing.
Bingo.
For the CPU. Cool.
It's a platform for running your code. Same way like the Unreal Engine, you write all your like game logic and stuff, and it is running on the Unreal Engine. You write all your JavaScript code, and it is running on V8 and WebKit and Gecko.
Very cool.
Node is V8 yanked out of the browser as a standalone thing. This guy named Ryan Dahl, the V8 engine's open source, so he took the code from it. He's like, I wonder if I could run this outside of a browser and just have a way to run JavaScript code without the DOM and all the other things that like the browser kind of integrates, but adding in some things that browser JavaScript can't do, like accessing your file system and like seeing your processor and like a lot of like lower level things. So that's what Node is. It's just the thing that runs JavaScript in Chrome browsers as a standalone thing. All right, onward. Other questions about debugging? All right, so let's talk about data types. So there's 8 types in JavaScript now, but our everyday types are bread and butter. Strings, numbers, Booleans. That's those are our like basic primitive types. They're not reducible down any further. Strings are any text. Numbers are anything that you do math with. Booleans are the values true and the value false. That's it. So accompanying those, you have null and undefined. So those are also primitive values. We call those like our kind of like our empty values. So null is something that's intentionally blank. Undefined is something that is unintentionally blank. So for example, if I try to log a variable that doesn't exist. Doesn't exist is undefined because it has never been defined. If I wanted to declare doesn't exist, but I just don't know what the value is yet, I could initialize it to null. Now, in practice, you generally don't assign things to null. So like whatever this is supposed to be, like if it's a name, but I don't know what the name is yet because it's coming back from an API or something like that. All of these have empty values. So like the empty version of a string is an empty string. The empty version of a number is 0. The empty version of a Boolean is false. So it's almost always better if you don't know what a value is yet to use whatever the empty value is for this instead of trying to assign something null. Never assign something undefined. There's no good reason to do that. Other types. Symbol and big int. Those are both newer. You will never use them in this program. No need. And then our only other type is object. These are the types in JavaScript. Ask me some questions about them.
Aren't all of these an object technically? Like
okay, so that's a great question. No. Objects are objects. Everything else is a primitive. Now, when the code is running, all of them are treated as objects. That's that boxing thing I was mentioning earlier, where like strings have a .length method on them. Well, how do they have a .length method if they're primitives and not objects? They get treated as objects when the code is running. Like I said, that is the single most complicated thing in all of JavaScript. But it's more useful to think of all of these as primitives and all your objects as objects than thinking of all of these as objects. Questions about primitive types?
If you set the value to parentheses,
Mm-hmm.
I mean, is that the same as null, or is that what the actual variable would be set to?
So parentheses are a way to force order and grouping, but they aren't values themselves. So if you did this, oh, it's not even valid syntax. Yeah, it's got to have something in there. You see how it's barking at me? It expects an expression.
Gotcha.
Other questions about types? There's a couple different kinds of object. There's ones that we make ourselves. Arrays are objects. Functions are objects. Promises are objects. DOM nodes. All of these are different kinds of objects. You can give me a good definition of an object. Let's give it a shot.
Something that has a key and a value.
Pew! There we go. Keys and values. But yes, all of these have keys and values. So let's take a look. So if I do, if I have to make my own object, I might say, all right, my name is Kyle. And the functions are just values, so I can also attach functions to this. So I do that, and then I have my own object dot name. I have my own object dot say. Oh, I didn't give it a message. Oops, I didn't use the message. Huh. Oh, that's weird. No, it just worked. Whatever. But the idea is that, yeah, it's key value pairs. Oop, there it is. So, key value, key value. Values can be primitives, like strings. They can be functions. They can be arrays. They can be objects. You have objects on objects on objects. But fundamentally, key value. It's even true of things like if I do function hello world. Oh, why this is acting so weird. All right, so I've got that hello world function. I can call it by putting parentheses at the end. Also, I can just look at it. Key, value, key, value, key, value, key, value, key, value. What about fetch? Or something that I make with fetch. Some promise. There we go. Key, value, key, value, key, value, key, value. Strictly speaking, we call these properties. And if it's a function, we call those methods. So something with a string value property, something with a Boolean value property, something with a number value property, something with an object value property, something with an array value property. Specifically functions method. Questions about data types in JavaScript?
So objects are data types, right?
Yes.
Not to confuse that. Okay, great.
Yep. They're a special kind of data type. They're where like pretty much all the magic comes from in JavaScript. They're also what we call reference data types. So what that means is that if I do const a equals 1, and I do, oops, actually I'm going to do this differently. If I do let a equals 1, and then I do let b equals a, and then I say, oh, never mind, a is 2 now. What do we think b is going to be? Actually, head over to inbox. That is not a rhetorical question. What is... Come on now. All right, questions out in inbox. Keep them coming.
Are you asking what it is or what it evaluates to?
Same thing.
Okay.
Keep it coming. Need 2 more, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so most of you said 2. Let's see what it is. 1. A is 1. B is what A is right now. And when A changes, B doesn't actually change.
Is that because the code is running sequentially? So when we make
Oh, sorry, Matt, you're a little quiet.
Oh, sorry, that was me. Is that because the code's running sequentially, and since we changed it further down, it's not going to go back and redo it, right?
Ding, 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 ding. So A is 1. B is A, which is exactly like writing B equals 1. And then A equals 2. Cool. I didn't change what B was. It doesn't track this and change whenever it changes. It stays the same.
So in order for it to be 2, you would have to do B equals A again
Right.
after changing. Okay.
Ding,
Gotcha.
ding, ding.
Thank you.
And that's true of every primitive type. So if I redid that as A equals false, B equals A, and then A equals true, B's still false. One of these days. There we go. It doesn't update. Same thing with
That
numbers.
makes sense.
A equals 1. Oh, we already did numbers. Same thing with strings. A equals A. B equals A. A equals B. B's still A. All the primitive types work that way. The reason that sometimes you'll hear objects referred to as a reference type, and these as value types, is that objects work a little differently. So if I do let some object equal me, and then I do let some other object equal some object, and then I change my name, some object.name equals Elise. Check this out. Some other object has the changed name. Only objects work that way. When you assign something to an object, it's not actually assigning the object, it's assigning a pointer to that object. And anytime that changes, that pointer is now pointing at whatever the new version of it is. That one does track. Primitive types, they're by value. Sequential. Doesn't go back and update something when some assignment changes. Objects, reference types. Reference types update. It also, and like the probably the most important reason to be aware of this is that like that creates an entire class of problems that you can have where you think that you're working with a copy of something, but you're actually working with the original thing. So you change the original thing, something else that's using it like is not aware that you changed it, or doesn't want you to have changed it. That's a whole, that's like one of the most common bugs that you're going to wrestle with in code. It's called mutation. So what I did, this is a mutation. I'm taking some object and I am mutating it into that. And so like mutation's dangerous. That's a really easy way to trick yourself. So that's one of the reasons that I'm so fanatic about making copies of things. Because like when you map over something, it makes a new array. It doesn't do anything to the original array. That's a lot easier. Or if I do const, let me blow that out. Come on now. Baby steps. If I do some object equals me, and I set some other object equal to a copy of that, and then I changed some object, I mutate it. Now some other object, still Kyle. That made a copy.
Why?
Because that's what spreading does.
Spreading. Okay. I was like, it's not called copy. I know those 3 dots mean something else. Okay.
Arrays work the exact same way. When you're spreading that, you are spreading it into a new object. So now those two things aren't connected. Questions
So
about,
in order to
go ahead.
change, like if you wanted to change some other object, you would do the same thing. Like you'd make another const and it would be equal to some other object. Okay.
It's way easier to do something like that than to keep mutating the same value. So, yeah, rather than having number is 0, number is 1, come on, number is 1, number is 2, or I'm just mutating the same variable over and over again, way better to just make a new variable each time. That's a whole class of problems that you just take off the table when you just make new copies. You get that automatically with the primitives because they're by value. Objects, arrays, promises, any of that kind of stuff. Way easier to just spread it into a new thing. Use something like map or filter that automatically makes a new copy. That's a saner way to do that.
That makes a lot more sense because when I was looking through Code Academy, they were talking about mutation and it was in reference to arrays.
Yeah.
So just changing whatever index it was to a completely new one.
Yep.
So that makes a lot more sense.
Excellent. More questions about types? So another thing that's true of types is they define what things we can do with them. There's 2 parts of a type. What kind of values can it have? What kinds of things can you do with those values? So like that's probably easiest to understand with Booleans. Because the entire range of Booleans is true and false. Is the only legal values. Versus numbers, where a legal number is like, let's see, it's the smallest thing you can do. Number min. There you go. So anything that's lower, that's between that and that, or something that can do, or a floating point. So a floating point is how decimals are done with computers. And so like the way it works is the more decimal points you have, the less precise it starts getting. But the computer only knows beeps and boops. The idea of like a partial number is not like a native concept to computers. So we kind of have to approximate it a little bit. That's what floating point math is. So yeah, if I want to do decimals, the more decimals you have, it's just taking precision out of it. So with Booleans, true or false. Numbers, any number that's between those two things or is a float that can be expressed with that same amount of space. Strings, any alphanumeric collection of characters. From an empty string to the collection of all of the world's novels together. Now, I think there's a limit to how long a string can be in JavaScript too. I don't know what it is though. Let's see. How long, oops. How long can a string be in JS? There we go. So in 2016, it was standardized as 2 to the 53rd power minus 1. That's a lot. And then those are lower in the browsers, it looks like. So Firefox limits it to 2 to the 30 minus 2. That is a ton. So that's the range of legal values for like these primitives. The only legal value of null is null. The only legal value of undefined is undefined. So that's one half of the like data type equation. The other half of it is what you can do with those. So a string, you can get its length. You can concatenate it with another string. That kind of thing. You can get something by index. You can see whether or not it includes a substring. Those are all legal operations on strings. With Booleans, our Boolean operators are what the legal operations are. So you can do or, and, or not. With numbers, our legal operations are like math operations. So plus, minus, times, equals, exponents, modulo. With objects, objects start getting a little bit more specific. But like the thing that makes all of these different, these types of objects, as a function, we can call it. And it will evaluate to its return value. With arrays, we can call .map, we can call .filter, we can call .find. We can access something by its index. A promise, we can then off of it, and we can catch any errors. A DOM node, DOM nodes have a children property, and they have an append method that lets you attach something to its tree. But that's what a data type is. It's a set of values that are allowed and a set of operations that you're allowed to do on those values. That's the definition of a data type. Questions about that?
If we wanted to get a complete list of what each thing can do, we just look at MDM for each one.
That's your best bet.
All right.
So like, for example, what can you do with arrays in JavaScript? This thing on the left, that is every method for arrays. Concat, at, entries, filter, find.
Why do they say prototype in between?
That's a really good question. I would not worry too much about it. That's another super complicated thing in JavaScript that is not important to understand right now. But the idea is that So some array is my array. So it doesn't have anything that I didn't give it, but it inherits things from its prototype, which have all of those functions. I didn't define any of these. Like, they came with the data type in the browser. So we say they're part of that thing's prototype. I could add my own things to this. I could do some array dot person. You can really do some pretty wild shit with this. So I could do something like that. I added that to some array. So there it is. All of these things just come with all arrays. So we say that they're part of the prototype. And I wouldn't think too much more about it past that. But the prototype is the stuff that comes with it.
Okay, thank you.
Just doing that, you didn't put the object in the array when you did this, did you?
No, I didn't.
That's
It still is an empty thing. I'm just illustrating that arrays are still objects. You can still do object-y kinds of things. You just usually don't. Same thing if I do some object, or sorry, if I do a function. So functions are just objects. So I can call the function. I can also like do key value pairs and stuff. There's not a ton of good reasons to do something like that. But there we go. There's my thing I added. But yeah, you want to find out what you're allowed to do on something. That's the big list. What are you allowed to do with numbers? You can parse them a couple different ways. You can see whether or not they're integers. You can see whether it's not a number. You can send it to a string. But yeah, this is the like encyclopedia of stuff that you can do.
What's the little trash can looking thing next to some of those?
Deprecated.
Okay.
So deprecated means that it still works, but it won't in the future. So it says not for use in new websites. So if you have it in your code already, that's a sign to start getting away from it. And then the exclamation point is probably experimental. Non-standard. That means that different browsers do it differently. But yeah, deprecation is a thing that you will see a ton in your career. Something will be the way stuff is done, and that like var. Var isn't technically deprecated, but probably should be. And then when it gets deprecated, that means stop doing any new stuff with it, and take your old stuff and make a plan for getting rid of it, because at some point in the future, it will probably go away. That's what deprecated means. More questions about types? And lastly, we have type coercion. So this is how we turn something from one type to another type. And really, these three will kind of take you the whole way. There's not a whole lot of other types that you need to coerce. You want to turn something into a number, put a plus in front of it. You want to turn something into a string, wrap it in that. Now, something that I see people do a lot is like doing this with things that are already strings. Not necessary. It's if you have a Boolean or a number and you need to turn it into a string, that's when you'd wrap it with a template literal. And then if you need to turn a string or a number into a Boolean, put 2 exclamation points in front of it. The first one turns it into a Boolean, but it turns it into the opposite of whatever it is. And then the second exclamation point keeps it a Boolean and flips it back to what it would have been originally. So it's like negating a negation, but in the process, it also ends up changing the data type. Questions about type coercion?
So the temperate literal one to change a number or Boolean into a string, we've been doing that in our API projects within, and that's all that's doing is just changing the type.
Not necessarily. You can also use template literals to build a template that you're plugging variables into. But if you just put a value into it, like for example, if I have some number and for whatever reason I need the string version of that. For example, I want to see how many characters it has. Well, there's no way to see how many characters a number has. There is a way to see how many characters a string has, though. So if I coerce some number to a string, some number as a string, I can put it in a template literal. And now I've got the string version of that number, which will show up whenever my browser catches up. There we go. So that was the number version. That's the string version. And that means I can do anything that I can do with a string, like some number as a string dot length. I can see that there's 5 characters in that. I can do stuff like reverse it. That's not a math operation. That's a string operation. Or not. I thought. Oh, it's because you can't reverse a string like that. You have to break it into an array first. So then I can make that string an array by splitting it. I can reverse the array. Then I can join the array back into a string. 5, 4, 3, 2, 1. Blast off. So juggling values between a couple different types, that's normal. You end up doing that a fair amount.
So when you split the array, you just had the double quotes in there. What did it actually do to it?
Cool, great question. So what the split method takes is a character to split on. So for example, if I had some kebabbed number as a string, that might be 1-2-3-4-5, which is especially useful if not all of these are the same length. So what I can do then is go, oh, I want to split that into an array. and say, everywhere there's a dash, split it there. And then as an array will look like that. It doesn't have the dashes anymore. It just used that to figure out where to do the split. If you pass it an empty string, it splits on every character.
Okay, so that number or that string was all of those things together,
Right.
and then you've broken them into individual pieces.
Bingo. Okay. Joining works the same way. If I put like a dash in the join method, these all get joined into one string with dashes in between them. Any more questions about coercion? All right. Expressions. So I think expressions are the thing that people had the hardest time with first time around on reading code. So before we dig into expressions, how about we go ahead and take a break there? I've been at this for a little bit. Let's get back and, let's call it 10 minutes.